Hey guys, welcome back to the second video for section 2.1. I wanted to start the video with a few things for you guys to think about. One thing is matrix addition commutative, right? So is A plus B equal to B plus A? Is matrix multiplication commutative? Is A times B equal to B times A? I kind of mentioned it in the last video. And here's the last thing. If you can add A plus B, can you also multiply them as well? Sometimes, all the time? Think about it. Okay, this only has 5 slides, so I'm gonna run through this. I'm trying to make the videos a little bit shorter, okay? So this video is on the systems of linear equation. It's extremely important. So imagine we have these 3 systems, okay? We have the A's to be the coefficients, the X's to be the variables, and the B's to be the constants, and the X1, X2, X3 is what we're trying to solve for. You're going to see a lot of this in your reading, okay? You're going to see a lot of this in your questions. A is the coefficient matrix, that's why I did it in red. X is the variable, and B is the column matrices or the column vectors, okay? The way that we can write this is A times X equals B. This is going to be really important also for inverses. So everything we do here is extremely important. What you would do is you would come up with your coefficient matrix, then your variable matrix, and then your constant matrix, right? And we're trying to solve for X1, X2, X3 here. And remind yourself this is called a column vector, right? It's a single column. Okay. So take a look at this. Imagine A is 2 rows by 3 columns. And imagine X is X1, X2, X3. And imagine our coefficient is the 0 matrix, okay? So it's just 0, 0. The way that we can write this is A times X equals B. A times X equals B. So I want to show you what happens here, okay? Let me get this highlighter. Actually, let me get rid of all the highlighted part. Okay, so right now, this is 2 rows by 3 columns, and then that's this guy here, and this guy here is 3 rows by 1 column. Therefore, you're going to have 2 rows and 1 column, right? So the point is you can basically multiply it out. So the way that we would do that, right? And if you take a look at the answer here, we have 2 rows, okay? Give me 1 second here. So so you can multiply this out and you're gonna get 2 rows and 1 column if they were numerical values. So here's what we're gonna do. We're gonna go like this: 1 times X1, negative 2 times X2, positive 1 times X3, and that's going to be this guy right here. Then we're going to do, right, to get the second, we're going to go 2 times X1, 3 times X2, negative 2 times X3. So as you're going across the row, you want to go down the column, okay? Across the row, down the column, okay? So the reason why we can multiply, once again, I don't know why I said this. I'm not trying to find the value, but I just want to show you that we could multiply it because these 2 guys match, okay? So what I'm going to do is I'm going to make that augmented matrix, which means it's going to be the coefficient plus my solutions. And then I'm not going to show you how to do row reduce, but we're going to do row reduced echelon form. And we come up with this here, okay? So pause the video if you need to, but basically this here gets to this. Now that we have that, I want you to think about it like this. We ended up getting this after we reduced it. This here is my X1, this here is my X2, this here is my X3. So 1 times X1 minus 1/7 X3 equals 0. Now, the next one we have X2 minus 4/7 X3 equals 0. So instead of choosing X3 to be T, because that's what we typically would do, and then we would write the other 2 variables in terms of T, what I'm going to do is I'm going to choose X3 to be 7t. The reason why I chose 7t is because I want to get rid of this 7 and make it nice. So if I choose x3 to be 7t, then what would happen for x1? Well, put 7t back in here. Let me get rid of all of this so you can see it better. Take 7t, put it back into here. Negative 1/7 of 7t is just t. Add it to the other side, you get t. Put the 7t in here, you get x2 minus 4/7 times 7t is minus 4t. Add that to the other side, you get this. So you get this. x1 equals t, x2 equals 4t, and x3 equals 7t. The reason why we have this is everyone should remember this from the first chapter. Guys, we have two systems of equations, but we have three letters. So anytime you have more variables than there are systems, then you're going to have infinitely many solutions, okay? So that's why we need to have that parametric representation. This slide here is the most important slide of our video today. I want to recap and finish up what happened. We had 1, -2, 1, 2, 3, -2. We're going to multiply that by x, and it was going to yield b, okay? So we have this guy here called ax equals b. And I was trying to solve for x, okay? So this has infinitely many solutions because we have more variables than rows, okay? So look at this representation here. Solving for x, we have obviously this x, which will be a bold print if you're reading, is equal to this column vector x1, x2, x3. x1 is t, x2 is 4t, and x3 is 7t. You can also write it as a scalar by factoring out that t. T times 1, 4, 7. Some of our solutions, depending on what you make t, if t is 1, you get 1, 4, 7. If t is 2, you get 2, 8, 14. If t is 0, you get 0, 0, 0. So solving for x, you have infinitely many solutions. Please take a look at this representation for x, and don't forget everything that I say about these specific terms. I'm going to try really hard to rewrap them, but scalar is one of the words. Infinitely many. We're going to be solving for x. Know how to write it. When you multiply, you need the insides to match, okay? I hope you all enjoyed this video. Come back for another video for section 2.1.